Okay, so we're going to take it from where we left off, and now we're going to look. We said that there are several steps in cellular respiration. So we're going to start with glycolysis, which is this top one that you see here on this diagram, and then take it from there. So glycolysis is of 10 steps, and it's when the cell is taking in glucose, and in order to take that glucose in and do something with it, it's going to have to transform it. And so it's going to transform it in these 10 different chemical reactions, all of which require their own enzyme. Now, I've done another video on educreations on this. It's more of one that I've drawn out. So you can take a look at that too. I've actually put a couple of them up already on Veracross. But let's just start with these slides. So we know that almost all organisms perform glycolysis. So this is a super important process in metabolism of all organisms. So we'd say that from the evolutionary standpoint, that this process is conserved, meaning that it occurs in all different organisms from the very simple up through us. It's going to happen in the cytoplasm. So that's important. And in this first part of cellular respiration, oxygen is not required. So what's going to happen is we're going to bring a glucose into the cell. So there's the input, and we're going to use that carrier that we talked about a little bit before, this thing called NAD. We're going to use this carrier molecule. We're going to use two of them actually. We're going to use 2 ATP. So in other words, we're actually going to use 2 ATP. We're going to see where 4 ADP come in. And then in the output of this, the goal is to make these things, which were a new molecule called pyruvate. So we're going to make 2 of those. We're going to have now this reduced form of NAD, which is NADH. So this is the reduced form. Notice it has a hydrogen on it, which means that it's not only got a hydrogen, which is a proton and an electron, but it also has another electron. So it's carrying electrons. Remember, that's an important piece of what a reduced molecule has. It's going to generate 4 ATP, and then we'll see where those 2 ADP are. All right, so let's go. So here's this first 5 steps, which we're seeing here of glycolysis. And sometimes I call this the investment phase. I'm actually going to move me off the screen. You don't need to see me anyway. So that you can see that here's glucose, and I showed you this before. And now we're going to take glucose, or the cell is, and it's going to use an enzyme called hexokinase. And using that enzyme, this is going to be normally from glucose to this next product, which is glucose 6-phosphate. This would be an endergonic reaction. In other words, if we just looked at this individually, we'd say, oh, this is one in which the delta G would be a positive value. However, we want this reaction to go forward, and so to make this reaction go forward, we're going to couple this reaction with the hydrolysis of ATP. So remember, lysis, hydrolysis, using water to release energy, to split something, to break a bond. So ATP, we're going to hydrolyze ATP into ADP. So in this process, this is an exergonic reaction. This would be a negative delta G. And therefore, when we couple these 2 reactions together, we can use that extra energy that comes from hydrolysis of ATP to drive this reaction to the right, which is this glucose 6-phosphate. Now, glucose 6-phosphate, if you notice on this picture, and I'll enlarge this in class, that you see that here's the phosphate right here. I'm circling it with my cursor. That phosphate is now on the 6th carbon of glucose, and that's why it's named glucose 6-phosphate. So this is the next reaction right here. So now we're going to convert glucose 6-phosphate into basically a rearranged molecule called fructose 6-phosphate. So notice the phosphate didn't leave. We have no input now of ATP. This is an exergonic reaction. in other words, it's spontaneous. It's going to move forward. If we were going to put a delta G value on this, this would be negative. Okay, remember, because that's an exergonic reaction. We have a new enzyme, this one right here. And this is an enzyme called an isomerase. So an isomer, remember, is just a rearrangement of a molecule into a different form, but same formula. So now we're changing glucose 6-phosphate into fructose 6-phosphate. Still has that phosphate on the number 6 carbon. And voila, we're on this next one. But notice going from fructose 6-phosphate, now we're going to create a new molecule called fructose 1,6 biphosphate, or sometimes called bisphosphate. And so in this case, we're going to again need to invest energy. We have ATP here. It's going to be hydrolyzed. The energy from this hydrolysis is going to drive this reaction forward. Here's the phosphate on the first. Here's the phosphate on the 6th. So we're still have that shape of fructose, but now we have a phosphate on both the first and the 6th carbon. And so hence we've got this new molecule right here. Fructose 1,6 bisphosphate. Now, this is a kind of an interesting 4th and 5th step, because in the 4th step and the 5th step, we do kind of two things. And these enzymes here, you don't need to know the names of them. But basically, the end result is that in this 4th step, part of this molecule is going to end up being this right up here, which is something you don't either need to know, dihydroxyacetone phosphate. And this one is a glyceraldehyde 3-phosphate. Again, don't stress over these names. I'm going to talk about these anyway in class. But what we get then is something that looks a little bit more symmetrical, don't we? So this is on the 1st carbon. This is on the 2nd. We've basically split this molecule into these two using these two steps of these enzymes. So you can see that there. This whole thing, this 1 through 5 step, is sometimes called the investment phase, because the cell is actually investing energy. Even though we know the goal of cellular respiration is to make ATP, we're actually using 2 ATP in this first 5 steps. So this is the investment phase of glycolysis. So the second half is going to be the payoff phase. And in the payoff phase, that's where we're actually going to net some ATP in the end. And so this picture down here is too far down for you to really see it. I'm going to move it up here a little bit if we can. That doesn't help much, but we'll look at this again in more detail. So the next set of steps, we have 6 through 10, we are going to do some more chemical magic with different enzymes, and we're going to end up with a molecule of pyruvate, and we're going to make some ATP out of this. So remember up here on that part we just stopped at, we split that molecule into 2. So now this is going to be, this whole series of reactions you see here is going to happen twice. So here's the whole thing in one fell swoop. You can see glucose, here's the first 5 steps. Now we have these 2 molecules here that ultimately both become glyceraldehyde 3-phosphate. And then we're going to take this glyceraldehyde 3-phosphate and we're going to convert it in these next series of steps into pyruvate, 2 pyruvates, because we have 2 of these. Each of them is going to go through this. And then those 2 pyruvates are going to be going to do something else in just a few minutes. But we have here ADP being converted to ATP. So notice where the arrow is going. Here's another ADP going to ATP. So we've made 2 ATP. So if we just stop there, we'd say, oh yeah, now we've gotten back the ATP we already spent up here in the investment phase. But remember, this is going to happen twice now, because we made 2 of these molecules of glyceraldehyde 3-phosphate. And so we end up now with 2 pyruvates, 4 ATP, okay, at the end of this process, and those carrier molecules, so we'll come back over here, we're going to find that we're going to make 2 NADHs. So we're going to create a more reduced form of NAD+, and we're going to be able to use that going forward from this into the next act of cellular respiration. So I encourage you to look at this video that they offer to you on OpenStax. I think it would be helpful to you in getting kind of a feel for what's going on up to this point. And then we're going to go on into the next act, which is what I call the link reaction, and OpenStax calls it oxidation of pyruvate. So stay tuned. We'll do that next.